Okay. Does anybody have any questions from the previous session? I already post the notes. Probably from today, I will write a smaller more and show the screen in a bigger format. So hopefully it's going to be better. Anybody has any question up to now? Yeah. What I'm going to do, so probably tomorrow. So tomorrow morning, I'm going to post the homework. For the next, the deadline is going to be next Friday. So you have 1 week to solve all the homework. So all the homework is going to be about asymptotic notation. So some of the things I teach this week and some of the things I'm going to teach today. So, and you need to just finish that one. So, and then probably I'm just going to repeat some of the other concept on Tuesday too, because Monday is a holiday. So we need to repeat some of this concept on Tuesday. Probably if you have any question, you can ask on that time. So I'm reaching to university to see if we can get graded or TA. So I will let you guys know. Anybody has any other question? Okay. Sounds good. So we will wait. So can you see the quiz? Okay. Yeah, probably I'm just gonna, let's see. We will wait a few minutes. And then what I'm gonna do, let me see. I changed the access time. So the access time is a little late. So it means that, okay. So let's see. Okay, yeah, great. So yeah, in 2 minutes, you can get access to the quiz. You have only, how many? Yeah, you have only 15 minutes to respond to a quiz, and then we will get back to the course and I will teach other parts about like the other theorem that needs to be taught. So, and I will post two PDF, one homework in Canvas again. So hopefully everything gonna be fine. Okay. I think we are missing one person probably, but so I think in 1 minute you can start the quiz.
It opens at 5:10, not 5:15.
I just change it to 5:5.
Okay.
If you reload it, you can see it's gonna be 5:5. But just don't choose because it has 50-50. Don't choose like only so based on just guessing. Just try to calculate, do some writing, and then respond to a quiz. That's the reason I have it 15 minutes. It means that because it's just multiple choice, it doesn't mean that you need to choose one of them by random. Okay. You can start. So probably it's gonna need to be your code. Am I right?
Yes, we need the code.
So the code is gonna be quiz 2, but Q is gonna be uppercase. Does it work?
Yes.
Yeah, it works.
Great. The code is quiz 2 with capital Q. 8 minutes, so make sure that. Okay, so probably you have only 4 minutes. Okay, it's 1 minute. Let's start. Okay. Okay, so can you hear me?
Yeah, we can.
Yeah.
Okay, great. Let's continue. So I will try to write a smaller and be in the face, one page, so it's easier. So I talk about Venn diagram about all of the big O notation, theta or big omega, small. Also, let's try it again because I'm going to talk about some theorems here. Let's try to see, okay, if I have this one, so I consider this one is going to be big omega G of n. Then I will consider this one to be of big omega of G of n. What we have here, this part, so this is gonna be theta of G of n. And then we have two parts smaller, like this one. Here is gonna be O small O notation. So let me make this one bigger. So, and then let's do this last one, which is gonna be the small omega. Omega of G of n. As you can see how it works. So as I mentioned earlier, theta is going to be in the middle. So, and then we do have like big omega, big O, and then a small of them. So let's see. But it's really hard, you know, how should I know which one is going to be a big omega, theta, or big O notation? There is a theorem, so that talk about this one, how you're going to calculate this one. You remember from the previous example, what I see, for example, let's talk about like, bring one of the things that I explained earlier. So let's talk about a big omega, big O. How do you define big O? Let's define big O again. Say big O notation, G of n. What is that? Can anybody tell me to, then I can write it. Any idea? What is the definition? Probably you should study that one for today. Anybody? It would be really bad if 37 students in the class and nobody knows, and you study for the quiz, you don't know what is a big omega of G of n. Okay, yes, okay, let's start. We say all the function that exists such that there exists a C positive and there exists a naught, which is positive, which such that for n, all the n's greater than equal to a naught, what's going to happen? We say that what? We say f of n is greater than 0 and smaller than Cg of n. Is it clear? Okay. So we talk about this one actually. So let's go to the next page. So, okay, I already know this one. You remember what I decide, what I say, if you don't want to run this way, what you can do is take okay, divide everything by g of n. So it's going to be f of n by g of n between 0 and, it's what I tell you earlier. So okay, divide f of n by g of n. So it's going to be between 0 and c. You remember, just dividing this one. You say f of n by g of n is going to be between 0 and c. So, okay, I got this one. So this is a definition of like what? It's definition of like a big omega, big O. But I want to find the formulation, makes it easy for me any other time. If I give you any question and ask you, is it big omega, big O, or anything, it's easy for me to understand how to respond. So let's see what is the theorem. The theorem tells us if you find this limit, as I explained earlier, so it's okay, find f of n, divide by g of n, and get the limit to infinity. You find it as a variable L, and then say where L is between 0 and infinity. Less than infinity, it means it's never going to be infinity. If this the case, then what you can say that f of n is big O of g of n. You just need to calculate this one. That's it. It means if I calculate this limit, and I found this is equal to number, it can be 0, but it shouldn't be infinity. That means that f of n is going to be O of g of n. That's it. But one of the really important things, I will add it here. Warning. So converse is false. What does that mean? It means if I have a function which is going to be f of n is equal to omega O of g of n, it doesn't mean, but because of that, this limit is going to be between 0 and infinity, 0 and infinity. It doesn't mean that. So, but if you divide it and find the limitation and it's become between 0 and 1, for sure it's going to be big omega. But there is some big omega that this function doesn't hold. So converse is not true. Does it make sense? Is this clear? Does anybody have any question? No question? Probably, I think only one student is in the class, that the person that's writing the chat. Nobody else?
There's a couple other people, I think.
What?
I think there's a couple more other people.
Yeah, because at the end of the day, what's going to happen, as I told you guys about attendees, I'm gonna remember people based on the response in the class. Other than that, you're how many? 35 students, and I'm not gonna remember all the people's name. But probably if you respond, if you just engage in class, I'm not gonna forget. So that's the thing. Okay. Does converse but using big omega work? Yeah, I will talk about big omega too. It doesn't mean that I'm going to talk about this calculation just found big O notation. That's it. I will tell when you are going to have a small omega, when you have a small O, when you have big O notation and big omega. So now we found the first one, which is going to be big omega, big O notation. Let's prove it. What does that mean? How it prove it? Let's prove it. So let me put the proof in the next page. So proof. What I'm going to say, okay. What is the limit saying? Limit statement says what? Based on the math, if you take a math class, limit says there exists the epsilon such that for n naught greater than 0, and for any n greater than equal to n naught, this is going to be the case. This is the definition of this is the definition of limit. So when you say the limit, it means that f of n divided by g of n minus L is going to be less than epsilon. This is the definition of the limit. What do you mean, can I write the converse? It means that if I do have, the converse means if I have f of n is big O of g of n, it doesn't mean that limit of f of n where g of n equal to infinity, L is going to be between 0 and infinity. It is not going to hold. This is not going to hold. Maybe I can write it in red. If I found this one, it means that f of n is big O of g of n. But if you have it, if you know it's big O, it doesn't mean this is going to be hold. Does it make sense? Okay. So now based on the limitation, this is the definition of limitation. What does that mean? It means since this holds for all epsilon greater than 0, then what we are going to have, we can choose epsilon to be equal to 1. Let's consider that one equal to 1. And then what we are going to have for all n greater than equal to n naught, what we are going to have, let's put it consider to be like 1. It's going to be f of n divided by g of n minus L is less than 1. And then if I use like the absolute, it means that f of n minus g of n, f of n divided by g of n minus L is going to be between 1 and minus 1. We know this function is going to be, it means that f of n divided by g of n is less than L if I put L the other side. That means that the limit is going to be less than L, so it's not going to go to infinity. So that's the thing that's going to happen. Does it make sense? This is the proof.
Yeah, I get it.
Because, we find a limit and show this is going to hold. You remember, we show that f of n or g of n is greater than 0, less than a number, which is going to be L. So that's the thing. So that's the proof. So let's for example, show this one. This is going to hold, and then let's keep going. So we say, okay, this implies, what does this implies? This implies that f of n, the other side is true, greater than minus 1, which is nothing. So the other part is going to be, is less than L plus 1, as you can see. What does that mean? This means f of n is less than L plus 1 g of n. I know this is going to be greater than 0 for sure. This, what is going to tell me, this part? What this part showing me? Can anyone tell me? This is going to be a C. This is the proof. It means that f of n is between 0 and less than C of g of n. This is the proof of big O notation.
Yeah, of course.
So that's the thing. I prove that if I have this limit holds, it means that limit holds. It means I can show this is big O of n. That's it. It's done. Does it make sense?
Yep.
Yeah, so that's the thing that we are going to do. So what we can say here, when we do this one, we can say for there exists C greater than 0, because we consider this one to be C. And we see C is L plus 1. C is L plus 1. And then what we can consider, we can say consider n naught, because greater than 0, such that n greater than, for n greater than n naught. So that's the whole. Everything is whole. So we have everything ready. We already know that this is going to be, that's this part. Let me write this one actually in another color. So this is shows that f of n is going to be big O of g of n. Make life easier for you guys. Just what you do, You just just divide f of n by g of n, get the limit, find the number. If it's between 0 and infinity, so done. It's gonna be what? It's gonna be like big O notation. But let's see. If it's not, let's calculate. I have another theorem. So probably I will calculate, but it's not going to be between 0 and L. So what's going to happen? There is another theorem. What does that one say? It's the exact same thing. It's if limit, I got the limit of f of n divided by g of n goes to infinity. I will find this one in this time. But this time, L is not equal to 0, is between 0 and is equal to infinity. It means is previous time we say it's gonna be equal to 0 and less than infinity. But here we say, okay, it's gonna be between 0 and infinity. If that's the case, then what we can say? We can say that omega, like what we can say? Okay. We say that f of n, it means that is big omega of g of n. Somebody can ask me one question. If you go to one diagram, you can see there is a part that between big O and big omega was like, it's going to be intersection, this red part. That's the part that you can see from the limit too. Because this limit, 0 is not part of the limit, infinity is part, but there is something in middle, between 0 to infinity. You can see it in the previous one too. Previous one has 0 infinity too. Yeah, it doesn't have 0, but it doesn't have infinity, but it's going to be between those two. So it means that that's the part that we have intersection. So that's probably where we have theta. So now we prove, if I calculate this one, this is going to be the case. But again, we say warning, converse is false. Again, we talk about converse. We say converse is false. Does it make sense?
The converse of f of n of.
The converse means, let me write this.
I know what the converse is. I'm just saying of fn of theta g of n.
If this is the case, it doesn't mean that this limit is between this L is between 0 and less than equal to infinity. Is not the case. Let me write it. It means, oh, let's see. This is not true. Does it make sense?
Yeah, I understand converse. I was just asking you about which equation you're talking about.
This one, talking about that if I know that this is this is not gonna hold. So let's go back and let's prove it again. So let's show the proof. Okay, let's see how we can prove this one this time. We say the proof. We say, okay, what this limit shows us. Limit implies, what is this one is gonna show? Again, let's do this one. F left limit of g of n divided by f of n. You know why? Because here, this is going to be between 0 and infinity. I cannot prove anything. But what I can do, let's reverse this one. Instead of f of n divided by g of n, if I just converse this one, makes g of n divided by f of n, it's going to become 1 divided by L. So it's going to be between 0 and infinity again. So I just convert this one, and I put this one L prime, where L prime is equal to 1 over L. You know why? Does it make sense? Because I just convert that, because it was like f of n divided by g of n equal to L. Now I just reverse that. It's become g of n divided by f of n, it's become L prime. So let's see. If this is whole, what is that gonna give me? It means that based on L, if L is 0, this is gonna be infinity. L prime, this is going to be infinity, but there is no equal because there was no equal when it was 0. And if it's infinity, 1 divided by infinity is equal to 0. That's again is going to be the same as what we have. So what we say that g of n if I have this one hold, I said g of n is omega, big omega of f of n. And then there is another theorem. What does that say? I explained it the other day. We say if g of n is O of big O of f of n, it means f of n is gonna be big omega of g of n. This is the proof. Because I know it holds. If this one holds, this is gonna hold. Does it make sense? Yeah, what is your question? Let me see. If the limit of f of g, if f g is gonna be L and L is between 0 and infinity, so here, L is between this one. Reverse it. If I reverse this one, put g of n divided by f of n, it's gonna be 1 over L, you know? This is gonna be the region, so I'm just converting that one. If I put L equal to 0, 1 divided by 0 is becoming infinity, but there is no equal. If I put infinity, 1 divided by infinity becomes 0, but there is equal, so that's become this part. This part become equal. Does it make sense? Okay, let's see. Okay, makes sense. Great. Okay, we did everything. Okay, now what I know, this is a concept. Let's do the concept. So what I'm gonna do every time, let's write the steps. First, I got the f of n. I have a g of n. I got the limit, n goes to infinity. I found this L. There are possibilities. First, L is between 0 and infinity. This is the first possibility. There is another possibility is between this one. As you can see, they have overlap. There is some places. This means that f, let me write it smaller actually. This means that f of n is big O of g of n. If this holds, it means f of n is big omega of g of n. Does it make sense? Is this clear? Okay, so let's do something. I talk about this one. You can see between this inequality, there is some parties between them that is going to be like overlap. As I explained earlier, this overlap is theta. So now we figured it out when we can consider theta. So how we can consider that one? It's easy. Once again, there is another theorem. What does that say? Again, if I do this one, if I find the limit, f of n divided by g of n, n goes to infinity, I found this one L, where L is this one between 0 and infinity. You know, this is the overlap between these two, the first one and second one. If this is the happen, then what we say? We say f of n is big theta of g of n. So one note again. Warning. Again, converse is false. The reason I explain this one, because if I ask in the final exam, for example, I just give you this equation and say, okay, we do have this one, we have this, we know that f of n is like big theta of g of n. So this is going to be correct. Because this is a converse version, you should say false, is not true. That's the reason I says warning, converse is not true. Does it make sense? Okay, let's give an example why we talk about this one. I want to talk about an example. Let's consider g of n example. Consider I give you guys g of n equal to n, and f of n is 1 plus sinus of n multiplied by n. So if I plot this one, actually, let's plot it. This is n. Plot shows this is gonna be definition of, if I can remember, let's see, better probably. So let's draw this line. Let's consider 2g of n. G of n is n, it's gonna be 2n. This is the definition. And let's draw this function. This is gonna be f of n. This is the plot of 1 plus sinus of n multiple n. So obviously, what do you see? If you see this plot, what do you say? Based on this plot, what is obvious? Oh my gosh. From this plot, based on this plot, you should say what is the notation? What is the notation here? Anybody? How do you say the notation? Look at the plot and tell me what is the notation.
I'm not sure, big O,
What? Big O. Why?
because after a certain point, it's over f of n.
Yes, it's because it's upper bound for n. So we say, okay, I know for sure. Let's see. You just look at the plot and say, okay, this is the upper bound. So what I'm gonna say, I say, okay, obviously, based on the plot, f of n is big O of g of n, for sure. I'm sure about that one. But if I look at the plot, this, like, g of n is not lower bound. So since it's not lower bound, I'm sure f of n is not equal to omega of g of n. For sure, I'm sure about that one, because it's not lower bound. It should be lower bound, it's not. So then let's do this one. Let's do f of n divide by g of n. Find the limit. Find the limit. Limit n is equal to infinity. If I divide this one, it's become 1 plus sine n. Let me write it better, sorry. Because this n is gonna be like removed from the equation, it's become inus. But one thing, this function doesn't have limit at all, has no limit. That's the reason I say converse is not true. I know for sure f of n is omega, big omega of g of n, but I could not prove that limit exists. You remember, I told you guys here, like here. You say, if I have this limit, it's big omega, big O. I know this is big O, but I could not find the limit. That's the reason I say converse is not true. Because I know for sure, I know that this is gonna be big omega, but I could not find the limit. That's the reason converse doesn't exist. Does it make sense? Is it clear? Okay. Let's go to another example. Let's see. Let's do another example. We want to see, is it the converse true or not? Let's consider again. G of n equal to n. F of n is equal to 2 plus sine n multiple n. Let me draw this one for you guys. It's not obvious a little. So let me do 2 lines. One of them is this one, which is gonna be 3g of n. It means 3n. And let me do another one. This one. This is gonna be g of n by itself. G of n. And let's plot this f of n. F of n is gonna be like this. So this is f of n. So based on this plot, what is this relationship? What is the notation? What is the notation? Anybody? No, it's not big omega. Big theta, yes. Why? When I have an upper bound, it's gonna be big omega. When I have a lower bound, it's gonna be big. So if I have an upper bound, is big O. If I have a lower bound, is big omega. If I have like a sandwich is in the middle, as I remember, I explained about two rabbits and the turtle is between. So it means that what is gonna be big theta. So it's gonna be f of n for sure. I know based on this plot is theta of g of n. But again, let's see. Let's calculate the limit. So limit is gonna be f of n divided by g of n, which is gonna be 2 plus sine of n. This doesn't have any limit again, has no limit. That's the reason we mentioned that we mentioned that the converse is not true, because this limit doesn't exist. I know it's gonna be whole, but the limit doesn't exist, so it means that the converse is not true. Okay. Does it make sense? If it makes sense, let's draw a really nice diagram. So, okay, let me draw something. Okay, this is a really, really important actually graph. So we are gonna talk about this. Let's make right really. Okay, I need border a little. So let's write nicely, and then I will explain. Okay, so I do have this one. Let's do something. I just put like a middle, like red one. This part, as I explained earlier, this part is gonna be theta of g of n. And then I have another part. Let's divide this part actually. No. Let's divide this part. Okay, so this part, this is the theta m. It's where L is between 0 and infinity. So this is the 0 and infinity. Here is when L is equal to 0. Here is when L is equal to infinity. So if I consider this part is gonna be O of g of n. You know why? Because this is the definition. And like, no, sorry, let's see, let's do better. This whole part, this part is gonna be omega, big omega of g of n. This is gonna be big O of g of n. This is gonna be big omega of g of n. This part that has this. Let me see if I can draw it like this. This part is gonna be this big omega, and then let's try another color. So this part is gonna be this, because they have overlap. That the middle part is theta, but you know, the upper part is where we don't have any limit, no limit. So if I consider this point A, this point B, and this point C, it means this part is where you don't have any limit. Limit doesn't exist, no limit. Here is the part that limit L exists. So if this L is between 0 and infinity, it's gonna be theta g of n. If L is here, it means it's a small O of g of n. if L is this one, if L is equal to infinity is omega of G of N, a small omega. So does it make sense? Let me write it. So let's see. What we do, we say let's find a limit f of n, g of n, n to infinity. There are some possibilities. L doesn't exist. If L doesn't exist, which is going to be above? It's going to be A, B, or C. A, B, C doesn't exist. It means it can be big omega, it's going to be big theta, or big O. Any of these. If L exists, there's so probably. If L exists, there are three possibilities too, but that's easy to understand. If we consider L, if L equal to 0, we say it's a small o. If L is between 0 and infinity, we say it's big theta. And if it's L is equal to infinity, it means it's a small omega. It's easy. Just look at it and you realize, oh, that's the case. Does it make sense? You got it? Okay, let's do an example. Let's see how it works, for example. Okay, I do have this one. Let's see if the final exam question. So I have this one, n plus a power of b it's theta of n power of b for b greater than 0. Somebody tell me, what is this? Is it big omega? Is it the small omega? What is that? No, that's the question. This is the question. Is it true or false? Because I already put it theta. Can anybody tell me, is it true or false? And how do you do it? If I give you this question for final exam, how do you consider that one? What is the first step? As I explained, somebody mentioned, what is the first step? You can unmute yourself and do that. Yeah, okay. First step, I say, okay, I want to check this one. Let's do it. Let me use another color, actually. Probably this one. So let's say, okay, first step, find a limit. I say, okay, limit. This is going to be f of n. This is going to be g of n. Let's divide this time. So n plus a power of b divide by n power of b. N goes to infinity. Let's find it. Okay, how should I write it? I say let's limit, because b is similar in both. So I can put this one here. It's going to be n plus a divided by n. N goes to infinity. Based on definition, if they are the same rate, this is a, it means that if n goes to infinity, this is going to be infinity. This one is going to be infinity. This limit, it means I can skip the a. So it's going to be n divided by n. So it's going to be 1. So it's going to be limit. It's going to be 1 power of b. So anything power of b is going to be 1. So now L is equal to 1. Let's go to the diagram. When L is not, L exists, so it's not above. So L is like, L is the second part, the lower part. Is L equal to 0? No. L is infinity? No. L is between 0 and infinity, which is going to be 1. So I can say, okay, because it's whole, and we can say, okay, it's f of n is theta of g of n. So I proved it. It's correct. So I say, okay, true. I can put this one equal to true. That's the way you just calculate this one for the homework that I'm gonna give you guys, or just for the final exam. Does it make sense? Is it clear?
Yeah, it's clear.
Okay. Let's solve another problem. Okay, that's a really interesting one. So let's do another example. Okay, let's go back. There is another exercise. If f p of n is a polynomial, if it is a polynomial of degree, it means the maximum degree. If the degree of k, then p of n is gonna be theta of nk. This is the maximum degree. But how it works? Let's do the proof. Does anybody know how it works? What we need to do, if we want to prove it, what is the next step? What is the next step? Anybody? Any idea? Yes, let's do the limits first. First of all, let me define P of n. What does P of n mean? When we say polynomial of degree of k, it means it have nk. Okay, let me write something. It means this is gonna be an. It means this is the constant number an nk plus an minus k nk minus. And then it's going to go all the way to the constant a0. Let's write an example, for example. Oh my gosh. Write an example. So for example, P of, I don't know, 3, we can say it's going to be 2n cubed plus 2. That's the other things. An is going to 2, the other is 0, and then we have a0. Yes. Now what we are going to do, I know what is the P of n. Let's find the limit. So how do you find the limit? So limit was f of n, which is going to be P of n. P of n divided by g of n. N equal to infinity. Let's divide. If I divide by nk, because g of n is nk, the first one, if I do the division, nk is going to be removed by nk. First, this is going to be an. The second one is going to be ak minus a, sorry. Yeah, let's put this one actually. Let's put them ak because it has k of them. K minus 1 a0. This is going to be ak. This is going to be ak minus 1 and then divide by n and then goes all the way to a0 nk. Because we just do all of these things. And if n goes to infinity, one number divided by infinity, this is becomes 0. N goes to infinity. This one is becomes 0. Everything, because n is in the division, everything becomes 0. The only thing gonna stay is become ak. So this means that limit of Pn divided by Gn, n goes to infinity, become ak, which is going to be greater than 0 because this is the highest degree. This ak is never going to be 0. So oh my gosh. Okay, so this is going to be greater than 0. What is going to prove us if it's greater than 0? This is where we say ak is between 0, but it's not infinity. So that's the way. If I go to this graph, is when it's between 0 and infinity, is going to be theta. So we prove that this one is P of n is theta nk. Does it make sense? Is it clear? Okay, sounds good. So let's see. Let's let's do another example. That's a really interesting one. Okay. How about this one? I want to find a relationship between n to power of alpha, and this is going to be, I don't know what is this, and n to power of beta. So what is the definition? What do you say about this? Is it theta? Is it omega? Is it big O? How do you calculate this one? What do you say about this? What is the first approach? What do you want to do? But why theta? How do you start it? Let's do as I want to give you a steps to do that. What is the first step? Let's start to write a step. What is the first step? If I give you this question, what is the first step? Anybody? Yes, limit. So, okay, limit. I say n alpha divided by n beta and go to infinity. So how do I write this one? Based on like definition, it's going to be n alpha minus beta and goes to infinity. But now, because of this, there are three ways to define. Let's see. If alpha is equal to beta, what's going to happen? If this is equal, it means alpha minus beta is going to be 0. N power of 0 is going to be 1. Am I right? Am I right? Okay. So this is the first one. But if L is greater than beta, what's going to happen? It means this is 3, this is 2. It's going to be a positive. N power of infinity power of something positive. This is going to be infinity for sure. But let's see. If it's a smaller, that means n is to the power of something minus. It's going to be 1 divided by n. N goes to infinity. This is going to be 0. So we have 3 options. So now we cannot say, oh, this is going to be, this black box that I wrote have 3 options, because it's going to can be 0, can be 1, can be infinity. It depends on what is the number omega and what is the number of alpha and beta. So what am I going to say? I can say this is a solution. It's going to be n to the power. It's going to be 3 options. The first one, alpha kuchiktar as beta. What was the other one? This is when it's smaller. The result is going to be 0. When it's 0, what does that mean when it's 0? Let's go back here. When it's 0, it means it's what? A small o. So I say, okay, I write it. This is going to be a small o of like n beta. But when is equal, what's going to, when is equal, I say when is equal, it means it's 1. When it's 1, what does that mean? When it's 1. What does that mean when it's n equal to 1? L is equal 1, it means big theta. Yes, because it's in the middle, so it's going to be big theta. This one. And how about if alpha is bigger than beta? We say if that's the case, it's becoming infinity. When it's infinity, what does that mean when it's infinity? It's a small omega. So it's going to be a small omega of n. Does it make sense? Okay, let's write an example. Now you guys need to respond to this question. Example. What is the relationship between n and 14 and 12? What is this? Can anybody guess? Any idea?
Omega,
Why omega?
because the first one's bigger than the second one.
First one is alpha. Yes, this one. Alpha is gonna be a small omega. So this is, yeah, if you take the limit, so again, we can do the limit, but we can use this theorem that I explained above. The limit is gonna be n for limit gonna be n14 divided by n12 n equal to infinity. What is that cost? So it's gonna be limit of n squared and go to infinity. This is gonna become infinity. When it's infinity, we say, what is that? We say infinity is a small omega. So it's gonna become, this is gonna be a small omega. But we can use this one here. It's okay, alpha is bigger than omega, it's gonna be a small omega. Does it make sense?
Yeah, makes sense.
Okay. So I will have something similar than this one in your homework. I have one example, but it's not gonna be this, but there's something similar. So you need to just know these things. For example, one of the question gonna be for your midterm is gonna be multiple choice, which is gonna have some of these. For example, I will add this one, and I say choose between, like, is it omega, is it big omega, theta, and something like that. You will just do it. Is it clear?
Yep.
Okay, sounds good. Okay, so let's see. I want to talk something really, the analogy. There is we can say analogy of what everything means. I want to just mention it and just makes it easy for you guys to understand what is that all of this means. I'm gonna explain this one and give you 5 minutes break. So let's see. I want to talk about what does that really means. If I want to make it really simple for you guys to understand. So if I say f of n is like theta of g of n, what does that mean? It means if I consider as a function, like going back and forth, it means x is less than equal to y, because it means it's going to be between, it's going to be, if I have here, this is going to be omega, it look like that this is going to be bigger. It means x is f, y is going to be g, 1 is going to be g. So it means that if it's that case, it means that x is greater than g. It means that is lower bound. That's the reason we have big omega. So if this is theta, and sorry, this is the first one was omega. Oh, sorry. This is O, so let me write it. If I have O, it means x is less than y. It means everything is less than g. So that is going to be upper bound. If it's like other case, it's going to be lower bound. If it's theta, it looks like they are equal. If it's a small omega, a small o, it looks like it's less than, there is no equal. And if we consider big, a small omega, it's like greater, but it doesn't have equal. This is some like analogy that you can consider, like when you compare it with like greater, less than, something like that. Does it make sense? Okay, sounds good. So let's see. I want to solve another. Okay, so probably that's enough. So I will give you guys 5 minutes or break, and then I will get back to other part. So just let's have 5 minutes break. Okay, so let's continue. So some of the most important things for your solving the homework problem, you need to have a little background on math. You need to remember some of the math part, like limits, how to calculate limits. You need to remember some of these things. So I will write a few notes on that. I will post more notes. So probably I will explain a little today, and then probably you can see it on the canvas. Some of you guys maybe have a really good understanding like of this concept, but I will just write it. And I will write it in another probably colors. This is not bad. So, okay. Here, this is the handout on common function. So you need these ones for the homework and final exam. What is the sum of this thing? Probably some of you guys remember this one, floor and ceiling. Function. So, okay, let's see. Let's X is being in R. So what is the definition of, like, first of all, I have some definition here. Definition of the floor, what does that mean? It means greatest integer less than equal to X. That's a definition for the floor. How about ceiling? And this is how maybe you see it in your homework. So what is that ceiling? See, ceiling is like least integer greater than X. So this is going to be the definition. So how we can write it in math, if I want to write it, so let's say alternative, you can say let another integer n in Z, which is going to be only possible negative number, and X in R. So how I define first one for the floor? I said n is equal to floor, so X. How do you define it? It's okay. If and only if X is between n and n plus 1. And for the ceiling, what I say, if it's n, ceiling, if and only if X is between n minus 1 and less than equal to n. Does it make sense? Let's cast
Yep.
it. So, for example, what is the floor of 2.5?
2.
Yeah, exactly. The smallest. And how about the ceiling?
3.
Yeah, probably this is something easy, but you need to know it because you need to calculate them. So, okay, let's see. There is a lemma, which makes it really interesting and important. There is a lemma. What is that lemma said? It said if we have X in R and A and B in Z, then what we are going to have? If X is between A and B, if and only if, it's like gonna be floor of X is between, the floor of X is between A and B. It means that if I have X between A and B, so the floor for sure is gonna be between A and B. You will see this one when you solve the homework. You need this one for calculation. So, and then if X is between A and less than B, if and only if, this is the ceiling. So it's gonna be ceiling. So probably if you have ceiling, you can just put this one instead in the equation. That's the first thing. And then there's something really important. So probably, maybe you don't remember this one. There's another lemma. What does that say? So if X again in R and M is in positive integer, then what's going to happen? So the first thing, the really important one, if I have the floor of another floor of x divided by m, if you have this one in your question, so you can get rid of one of the floor above, so it's going to be x over m. This is holds when m is positive only, positive integer. And then we have it for the ceiling too. It means if you have the ceiling of x divided by m, you can get rid of the inside ceiling. You need this one when you calculate that limit. You remember, if you calculate that limit, you need some of this if you have the limit like this. If this is the f, for example, or if the g. So let's see. There is another lemma. Why I say this is the example important. Let's talk about it, and then let me show one of the things. So I give you guys this example. For example, let's see. It's gonna be f of n is gonna be this one, x2, and g of n is gonna be, for example, x. And you want to show the relationship between f and g of n. This is the box, this is the block. So you need to know that. So first of all, you will convert, because there is two floor, you can convert this one to this one, and then you want to find the limit. So you know that floor means that it's between a and b, and then you can use x and find this relationship. I will explain later, but the reason I'm just behind of all of these, because you can use them for just simply find the example and find the relationship. That's all the purpose I explain some of these lemmas. Another lemma. So if I have a and b in positive integers and n in another positive integer, then what's going to happen? So I can say first, another n divided by a floor divided by b. So it's gonna be this one, n a b. You just can remove the floor. So, and then another one, like this two is from ceiling. It's gonna be ceiling of n over a divided by b. This is gonna be the ceiling of n a b. That's the result. That's some of the definition. Let's go to logarithmic. So how about log? So I say let x and a and b is in R, where x greater than 0, a greater than 1, and b greater than 1, 2. So then log of x in base of a is inverse of exponential of x in a equal to ax. So if you have this one, you can find this one actually based on this. For example, what does that mean? It means that if I do have this part, if I have a log of x by a, it's equal to x. If I have log of ax, again, this is gonna be x. You just can remove this one. And then, so probably one more thing is that we can add. We can say that x is equal to a log x star a. And then this is equal to, I can put this one, a is equal to b. This is gonna be b log b a. Let me write it better actually. X is equal to a log x, because this log and this a is gonna be cancel each other, and then I can say this is gonna be b log b power of a, and there is another power which is gonna be log x and a, and then I can put this on b log a b multiple log XA. Then if I just get the log F from both sides, it's gonna be log B of X is equal to log AB multiple log XA. So you can convert this one. You can use this one actually. Instead of putting log X in B, you can put log AB, log X in A. So probably this is gonna be a constant. So you can just reverse this one. So what does that mean? If I have this equation, what does that show me? This is equal, I can say this on. Log of XB is means instead of log, I put this one n, X is equal to n, log NB instead of log NA. That's a definition. That's one of the things that you can use. That's some of these like equation that you can use. So like A log, this is coming from mass, all of them. X B is equal to X log AB. That's another one. That's a really good one too. So that's one of the other one that we can use. Okay, does it make sense? I have another, what I explained yesterday, Stirling's formula explained earlier. So let n be positive. Then what we can say? We can say if you want n factorial, the definition is like 2 plus this one n divided by n. And 1 plus theta of 1 over n. This is a definition. You can use this one for homeworks too. This is some of the math in the background, there is a weaker version of this one actually. The weaker version is say n factorial is approximately is equal to 2 power of n and divide by e. So this is another definition that you can use. Okay, so let me write something. This is gonna be like, probably this is gonna be your next quiz. You can go and think about it, and then we are gonna have it in next quiz. One of the questions for next quiz on Tuesday is gonna be this one. Quiz. So this is gonna be this one. Log of n factorial. Is it? You need to prove this one. Let's see if you can prove this one or not. Is it true or false? If it's true, you need to prove it. That's the next quiz. So you need to use some of these, all the example that I saw. For example, I know what is the definition of n factorial. So just go here, use this definition. And then use some of the definition I talked about log. So use that one too. And then find this one. So just give you some idea. For example, I know n factorial is like this one. I got the log out of this one. And I talk about some of the example about how log works. Use that one. Let's find the limit, because you need to find the limit. I just give you some example. First, the limit, which is gonna be limits of the log n factorial divided by n log n. So find this limit, and based on the values, you can decide which one is it. Is it theta? Is it true or false? But for solving this one, I give you this definition of this n factorial, just get the log and do the division. So I got, this is all these things that I just explained, is using this one to simplify this fraction. So does it make sense? You understand what is the next quiz? First, one of the question for next quiz. Am I right?
Yes.
So just what you need to do, I have this one, true or false. The next one, you need to upload the document. So probably if you want to write it in notes or anything, probably it's fine with me. Just try to type it, I don't know. So just you need to do, first of all, you will find the limit. For limit, you need this n factorial. I give you the definition of this. You need to get the log out. So use this formulation to simplify and just do this fraction and get the n to infinity, get the limits. And then based on the number you find, you can say, is it theta? And you need to explain. For example, if you find theta equal to, I don't know, any number, you come here, n equal to 2. So, okay, because L is between 0 and infinity, so it's going to be a theta. For example, I don't know, you should try that one. Does it make sense? Okay. Sounds good. So I will upload this note first of all, and then I will grade the quiz. I will see if we can get like a grader or like TA, and then I will post the homework. The deadline for the homework is next Friday at 11:59. So make sure that you will submit that one before the deadline. And yeah, and then we don't have any class on Monday. Our next class is gonna be on Tuesday. Does it make sense?
Yep.
I don't know about how many questions are gonna be in the homework. I'm not sure. I will check. I didn't post it yet, so I don't know. You need to focus. Everything is gonna be asymptotic stability or asymptotic notation. Everything is gonna be here. So, and then about what was another question one of the students got? So what was that?
Thank
Oh,
you.
You're welcome. So anybody that doesn't have any question, you can leave. Have a great evening, and then have a great holiday too. So probably long weekend. So